Welcome back, Zane Pusilowski, Kennesaw State University, Mechatronics lab down in Q118. This is the electrical portion of the lab. Now, the important thing in the electrical portion is what? Power, right? So the first thing we want to do is figure out what our prime mover or what our power is. So coming off this sketchy setup of how I've got my camera set up, we can see our power supply, right? In this case, we've got power that comes on and off and is super shaky. Make sure that you've got the correct voltage. In this case, I have an adjustable one where I can adjust the voltage. Hopefully you can see the needle moving. We'll set it at about 12 volts or so, and then we're going to kill it off. All right, so there we go. I'll try to get it set back up. And this is our attempt. Hopefully my camera doesn't fall down too bad. Okay, so the first thing is getting our power straight. We're going to have a 12 volt power supply, which is currently off. The second thing we want to do is we want to learn our valves. Remember we had our valves going on earlier, and we got to figure out what we want to control what and how it's plumbed and all those kind of things. Now each of these valves has a control cable for the solenoid on the valve. You got to make sure you got the correct end connectors for the correct kind of valve. Let's see if I can add one in here. So there's a certain kind of connector toward the end, and hopefully you got one that matches. Boom. So there's our control cable, and out of the end of the control cable are the ends for it. So let's think about what we're trying to do here. It's a solenoid, right? So I got to ground one side, boom, and then I'll have two things that come out. Hopefully they're labeled. Most of the time they're not. Sometimes you won't be working with new stuff, sometimes you will. You just got to figure out which side is which, and if you get it wrong, what do? You swap them. Yeah, doesn't have to be hard, okay? So we're going to ground one side, and then we're going to use the other to control the valve. And what do we have to give? Since we have ground on one side, what do we need to give to the other? We got to give a high, or we got to give power, right? Okay, so we're going to work our way through that. Let me put these cables out of the way. Try not to knock the camera down. Okay, so I've wired up our control valve, and I've brought it back to the board. I've grounded one side. Now, before we go too far, let's look at our entire board here. Very important to take a look, and hopefully it shows up on the video. Each of these, in case buttons, tells you what's going on. Now this one, is that a latching button or a momentary? That's a latching button, right? Now I've got a momentary button. I got another momentary button. When's a great time to try all this out? With the power off and before you wire it up, right? Okay, so first thing I'm going to do is ground my board, right? So I brought that over, and notice this little connecting line that comes over. Cool, that means those two are electrically connected. So if I have ground there, I got ground here, and then I'm going to take it to the other side of the board, and since I don't see any line or anything telling me they're connected, I'm going to put a jumper to ground one side of the board to the other, and then I've got a place to put my ground for the side of the valve, right? So now I've grounded the solenoid on the valve. Here's the big long cable for it. You can trust me that it's connected to ground, right? So I got the solenoid of the valve, which is right here, grounded, right? Then I'm going to take the other side, and I got to give it a high, right? So let's go back to our board. I'm going to bring power up to my control panel or my control board. I'm going to give power to one side of the board. I'm going to jumper to get power to the other. Most of the time, and we talked about this before, you'll have a rail, a power rail, and a ground rail, and that's real good practice. And then you'll have control sections of your control cabinet or your control panel. So we have given power to the top, and if you notice, I've brought power down to the top side of a normally open switch. So when I hit this switch, what's going to happen? I should get power from supply to here, jumper to here, power to here, jumper down. I'll have power on this side, and as soon as I hit that switch, I'll get a closed contact, and I'll send power here, right? I've got ground on the other side. Both of these go to my valve, so what should happen to the solenoid on the valve? If I hit this switch with power on, what should happen? And right now, notice nothing happens, right? I'll try to get all this junk out of the way for you. That's even worse. There we go. Okay, so let's keep an eye on the valve. We're going to turn power on. Let's check ourselves again. I got power, I got ground. Ground is grounded to ground, ground to ground, ground across. I've got ground to my solenoid. Cool, everything's grounded. That's nice. That way we don't get the crap shocked out of us. Now I've got power to the top rail, or the power rail. I've jumpered to fill the other rail, and I've brought power down to the top side of a normally open switch. Now I made sure I didn't use it normally closed, because that would be bad. It would immediately come on as soon as I turn the power on. All right, so let's turn the power on. What should happen? Absolutely nothing, right? That's good. That means we haven't screwed up yet. We've still got time to screw up. All right, so here we go. We think we got power there. We push this switch. What do we think will happen to this valve? We're hoping we power the valve, and since the other side of the solenoid is grounded, the solenoid will contact and do something, which you've got to look in the manual of the valve to see what it's going to do, right? Whether it's going to slide and open this port or that port, or connect this port to that port, or whatever. It's on the tech sheet, and remember it was on the diagram of the side of the valve. So let's hit the switch and see what happens. What happened? You can't see it, but there is a little light here, and it's saying that 14 just got energized. So 14 over here, which is probably some form of 4 or 2, is connected, and now whatever the valve is doing, we don't have air, we'd show you what it was doing. We now have power to here, and we've energized that side. Now what if we'd wanted to energize the other side, 12? So right now we got 14, what if we wanted the other side to be energized? Well, the first thing we do is we kill the power so we don't get the crap shocked out of us, right? Now we'll take the other side and we'll swap them out. Now we'll turn power back on. Now let's see what happens. Boom, the other side came on. Awesome. So if you had plumbed this correctly, and suddenly your valve wasn't extending or it was retracting instead of extending, maybe it's as simple as you were dumb on the wire, or maybe it wasn't labeled and you just swap sides. So it doesn't have to be any more complicated than that. Is that cool? So let's look through here. We got electrical power to it. We talked about learning your valves in the tech sheet and what they do. We talked about the valve cabling to the solenoid, because you always want to control your valving as precisely as possible. We talked about the power supply and getting the correct voltage, making sure also especially in industrial application, that you have enough current supply and that you have your breakers set correctly so that you're not going to oversupply or undersupply something. Supplying the right current, right voltage. We talked about the board panel and learning and studying what you're hooking up and what you're not hooking up. We got the valve to turn on for 14, and then we swapped sides and turned on 12. That was pretty cool. Next, we've got a setup to run a limit switch through a relay. So if you remember, we talked earlier about this little limit switch right here. Or it's actually just a switch, right? And we're going to use it because we're going to come out to a limit. So we're going to have a cylinder touch that, and then it'll swap the connection, either normally opened or normally closed, right? So I'm going to pause for a minute. I'm going to rewire this, and what we're going to do is we're going to run power through a relay on the board, which is right here, because we want to protect this switch. This switch can't take spikes in current, for instance. Maybe it's very precious, maybe it's expensive, maybe it's the only one we got and we want to protect it. So we're going to run electrical through a relay to use this switch. So I'm going to pause, wire that up real quick, and then come back and we'll finish that up. Okay, we're back. So now we've taken our limit switch and we have set up an impossible to see, especially on this camera. We've got the relay on the board, and actually I'll grab a different board for a second, so hopefully I don't knock everything down. Alright, so here's another section of the board. What we have are relay lines. So here's a relay, and then here's what it does. Here's a relay, and here's what it does. See the lines here, the dashed lines? So if I power the coil, so I give high power here, and I give, as soon as ground hits here, I'll contact or energize the coil, and then I will do whatever this says. So in this case, normally closed, in this case, normally open. So I might have a normally open, I'll have power here, and whatever I want to give signal. And then as soon as I contact ground here, the relay will energize and flip the switch. And then I can send power to a signal to turn on my valve, for instance, right? That makes sense? I know it probably doesn't, and it's going to be real difficult to see. So let's see what we've done here. We took high power from our power source, and we went in and we energized the top side of the coil. See that? Let's compare it to the same spot over here. I've energized the top of the coil. Okay. Then I came in and I said, I want to give high power signal to something. So here we go. I gave high power to signal. I know it's impossible to see. The point of all this is we're going to use a relay to protect our limit switch because we want to use our limit switch. Now, since I want the relay to contact, since I have power on one side of it, I need to be able to ground the other side. Hopefully that makes sense. Okay, so I've got power to the top side of the relay. I've got power to the top side that's normally open, and that's what I'm going to send to something when that relay closes, right? And then I'm going to use my switch. I'm going to run from ground to the normally open version of this switch. Notice I went 1 to 4. That's normally open. I'm in more and I'm in 4. So I've taken ground to 1 and signal from 4 back to the back side of my relay. That make sense? Probably not. But what I'm doing is I'm using the switch on the ground leg to give ground to the back side of the relay so that the power and the ground make the relay contact, and in this case close the connection and send high power from here over to my switch that I then can turn on my valve. So if you recall, and I think in this exercise there's a spot where you have to use a switch to then allow the next valve to turn on. So for instance, maybe a guard came and closed and hit this switch, closed it, then and only then do I want to be able to turn my valve on. And that might be the second cylinder. Maybe this is the gate, and then the next thing is the cut. So cylinder 1 would hit here and tell you, oh, the gate's there and people are safe. And then you'd be allowed to hit the switch and make the other cylinder snap something. So let's see what happens. I'm going to turn on power. Hopefully we don't let smoke out of something. We'll see. Okay. So right now, what's going on? What should be going on as soon as I turned on power? Nothing, right? That's good. Nothing's going on. We haven't let the smoke out of anything yet. All those are good news. All right. Now I have power to the top of the relay, and I've got the signal for ground coming through this switch. So if I hit this switch, what should happen? Can you see the little green light where you are? I don't think you can. Let's see. I'm going to pause and see if I can move this up a little bit so that you can see the little green light. Okay, we're back. Hopefully you can see the little green light that's going to come on. Hopefully, I'm not a very good weatherman. Hopefully it's going to come on right about here. Okay, so we have power to the top side of the relay. We're pulling ground through the limit switch. So if I hit this limit switch, I should get ground to the bottom side of the relay. I've got power to the top side, and I should energize that relay, right? Let's see what happens when I hit the switch. So my cylinder comes out, my gate is in place. Bang, did you see the little green light come on? So now I've energized the coil, right? And now I should take power to this. So I came through and I made this connection via the relay. Now I have a closed switch, so I'm taking power to here, which I'm taking to the top side of the switch we used earlier. If you remember before, we had power here, and as soon as I hit this switch, my valve came on, right? Let's hit the switch and see if the valve comes on. Notice the light did not come on the valve. That's very, very good. It shouldn't because we don't have power here because this relay is not on, right? So now I'm going to hit the switch. See how the relay is on? So now I have power over here. And if I hit that, my valve should come on. And I only need about 4 hands to get this to work. So there we go. Let's try that again. So there, the green light relay is on. I'm going to hit this button and the valve should come on. Damn. Didn't come on, right? Now what? What does that mean? We had switch here. We were good. We hit the switch there. Nothing happened. Okay, now, If you're like most lab groups, you would now spend about 15 minutes chasing all your wiring, and then you would ask me or the TA to come over and help you, and we go, hey, did you check your wiring? And then another 20 minutes later, you'd finish checking your wiring, and you'd be out of time and nothing would work. Now, I want you to notice something, and this comes from experience, and that's why we do labs like this, okay? When I hit this switch, I saw the light, but did I hear the relay? It didn't. Because if I look at my power supply, it's on about 10 volts. And I probably need more than that to energize this particular relay. So I'm going to turn it up. I'm going to hit this again. Did you hear the difference? Hear that? Really loud. Let me turn the power back down. Power's still on. See the light? I didn't have enough voltage to energize the relay. It would have taken me forever to find that. And how could I keep that from happening? I'd read about the relay I was using and what it needed to do. Okay, so here the relay came on right there. So let's try this again with many hands. Limit switch, gate comes down. Now I want to slice something, which is this valve is going to come on and send another cylinder out with a smasher or a slicer or whatever. Bang. Pretty awesome, right? Now, if that switch isn't engaged, I can't turn it on, which is good, because if the safety guard's not in place, I can't smash somebody. But if the guard is down and in place, now I can smash. Excellent job. Nice work. All right, hopefully you guys learned something there. Hopefully that helped you. The important point is I didn't screw up. I just didn't read the tech sheet to see what I had to do to get the relay to work correctly. All of these things are going to do exactly what you tell them to do. So if you don't tell them to do something correctly, they're not going to do something correctly. Okay, hopefully that makes sense. Hopefully you guys are doing well. Hopefully you enjoyed this awesome, high quality, extremely well lit video, and I'll talk to you guys later.